Hello Year 10, hope you're all keeping safe and well and working hard from home. In today's lesson I'm going to go through the questions that you answered for lesson 10, and I suggest you go and get yourself a green pen if you don't have one already. So if you don't have one, pause the video now, go and get yourself a green pen and then start back when you do have your pen. So our objective today, I can self-assess my work, and that means with your green pen you tick or cross your work, but if you do cross your work, then please make sure that you write in the correct answers. Lots of students don't do that, but it's really good exam practice that you do that, because when you come to the end of year 11 and you go to revise in your books and you just see crosses, you won't be able to learn from them. So please write the correct answers in if you have made a mistake. Which leads us very nicely to our second objective. You'll know where you've made the mistakes and how to improve it. And our third objective, which we'll do right at the very end, I know which aspects of this topic I need to revise. So let's go through these questions and fill in all the answers. So the first question is looking at an animal cell and a bacterial cell, and you can use your knowledge of an animal cell and a plant cell to help you out here. And it asks you, the first question, only the animal cell contains a what? Now it's multiple choice: cell membrane, cell wall, chloroplast, cytoplasm, nucleus. And you just look at the picture, you see there's a great big black splodge in the middle of the animal cell, and of course that is the nucleus. So tick it if you got that one right, please. If you didn't, then it's your time to correct it now, please. In the bacterial cell, you can see that there's like a line, like a rectangle line going round the bacterial cell. And the animal cells, they have the cell membrane, as do bacterial cells, but they also have a cell wall going all the way around that as well, similar to a plant cell. So cell wall will be your second answer. Okay, question 1b. We've got a cut section here of a leaf. So imagine you've got your leaf, you turn it to the side, and you've got the very tiny thin part of the leaf. That's what the image shows. And we're looking at one way Palisade cells are adapted to carry out their function. So how do they do what they do? So if you've ever picked up a green leaf from a tree, you'll notice that one side is dark green and the other side is pale green. And the dark side is what faces the sun. That's the top layer of the sun. That faces the sun. So your answers, how are Palisade cells adapted? You could say they contain many chloroplasts, and that kind of makes sense. You want them on the top of the leaf, because that's where they're going to do all the photosynthesis. There's no point having all the chloroplasts on the bottom side of the leaf, because it's not going to face the sun and it won't do photosynthesis. You could have said that it's positioned near the top surface of the leaf, or you could have said that the Palisade cells are packed closely together. And if you look at the picture, you can see that the Palisade cells are all packed nice and in a row, what we call the Palisade layer. So either of those for 1 mark. So tick it if you got it right, correct it if you didn't. Let's move on then. So 1C, nice multiple choice again. You just put the ticks in the right place. So is a leaf a tissue, an organ, or an organ system? And of course it is an organ. So hopefully you got that one right. And the xylem is a tissue, and the root, stem and leaves all together work as an organ system. If you got all 3 correct, you get 2 marks. If you got 1 or 2 correct, you get 1 mark. And of course if you got none right, then you get no marks, sadly. So tick it if you got it right, correct it if you didn't. Alright, 1D starts off multiple choice, and then we need to get a reason. So you get 1 mark for getting the box right, and then 1 mark for your reason. So students are going to observe these Palisade cells, these top layers of a leaf, through a microscope, and we need to know which objective lens should they use first. And they should always start with the smallest magnification, so that would be ×4 magnification, and there's lots of reasons for this. Let me move my head out of the way. You could have said that it gives the largest field of view, and if you look at the image that I've copied off Google Images there, you can see that's your field of view there. What you see through the microscope is your field of view. And if you go ×10 magnification or 40 or 100, what you'll notice that it gets smaller and smaller and smaller. So by having ×4 magnification, you actually see more of the cell. Okay, and that's kind of like what you want to do first. And then you kind of twist the microscope round, and then you can reduce your field of view as you zoom in to the structure that you're looking at. You could have also said it's easier to focus, so you go to ×4 and then you turn the knobs on the microscope, and then you're able to focus the image so it's nice and sharp. So either of those 2 answers would get you the 2nd mark. So tick it if you got it right, correct it if you didn't. Right, 1E. Let's move my big head out of the way there. Okay, so there's a couple of ways that you can answer this one. We've got two eyepiece lenses, times 5 or times 10, and we need to get to a combination of times 400, and we need to input an answer on the eyepiece lens and then input an answer for the objective lens. We do all that just to get 1 mark. So I'm going to start off with the first eyepiece lens of times 5, so this is one possible way that you could have worked this out. And because it says eyepiece lens times 5, we're just going to pop it in there, eyepiece lens times 5. That's nice and easy. But what do we do to work out the objective lens? Well, the total magnification is given to us as 400. So what we want to do is 5 times something equals 400. So my sum there is 5 times 80 is 400. So the objective lens must be times 80. So 5 times 80 gives you that 400. So that's one way that you could have worked it out, and that's fine, and you would have got 1 mark for it. But what if you didn't choose the times 5? What if you chose the times 10? So your eyepiece lens is times 10, so you pop that in your eyepiece lens answer. And the same as before, we need to get to a total magnification of 400, so 10 times what is 400, and that what would be 40. So your objective lens would be times 40. So this is the second possible way that you could have worked this out. So tick it if you got it right, correct it if you need to. And let's move on. So 1F, calculate the mean width of the Palisade cell images. Okay, move me out of the way again. So mean average, you add them all up and then divide by the number that there are. If you've got a scientific calculator, make sure that you do use your BidMash, your brackets, and all press equals after you add everything up, otherwise the sum comes out all wrong. So what we need to do is 12 and 13 and 16 and 10 and 11, press equals and then divide by 5. So my sum would look something like this. Work that out and it gives you 12.4 millimeters, and that is your answer. That is the mean width. So 12.4 millimeters, and the science exam is really friendly. If you rounded that down to 12 millimeters, then you'd still be awarded the mark, no problem. If you rounded up to 13, you've rounded it the wrong way, sadly. 12.4 is closer to 12 than it is 13. So 12.4 or 12 millimeters, please. Tick it if you got it right, correct it if you didn't. Right, G. This one's a little bit of a naughty question, really. I don't really like questions like this because it asks you to look back at other questions and other answers that you've done earlier on. So you really need to understand the question so that you're able to tackle questions like this one. It says calculate the real width of a Palisade cell. It gives you the equation, which is nice. It asks you to use the mean width you calculated just now, but then it's also got in the equation magnification as well. And you might be thinking to yourself, well, where's that? How do I know what the magnification is? Well, the image width we've just worked out as 12.4 millimeters. If you rounded it down to 12, that's fine. You just have a different answer to what I've got now, but you'd still be awarded the 2 marks. And in fact, any answer that you wrote for that, even if you got it wrong, you got the magnification correct, which is 400, and then you divided them to get whatever answer. You get what's called error carried forward, and you still get the 2 marks. But the actual correct answer is 12.4 previously. If you look in part E, it tells us the total magnification of times 400. So that is our magnification we need to use in part G. And then once you realise that, 12.4 divided by 400 gives you 0.031. And that there is your answer. So quite a tricky one. Hopefully you understand how to get that one right. If you got it wrong, really well done if you did get that one right. That was a tricky one. Okay, let's move on. So, question 2. So, a new question now. And we've got a figure of a scale drawing of a type of cell in blood. And what we need to do is give the width of the cell. And we use the scale to try and determine what the width is. Now, it's really friendly because they've given us a scale. It says 5 tiny little boxes is 2 micrometers. So, the way I would do this, we need the width, because that's what the question asks. And I know each one of my little red arrows is 5 boxes, so I just go across, and I know that each one of my little arrows is worth 2 micrometers. So 2 there, 2 there, 2 there, and 2 there. And to work out the total width, I just add up all the 2's, which gives me 8 altogether, because 2 and 2 and 2 and 2 gives you 8 altogether. You have to do all that just to get 1 mark. Tick it if you got it right, correct it if you need to. And let's move on. So question B, now this one is testing your knowledge now, no multiple choice, you have to put the correct part of the blood in. So the first one we've got carries oxygen around the body, and I'd be surprised if you guys didn't know this one. They're actually red blood cells. You get a mark for that one, and protects the body against infection. Isn't the red blood cells, it's the white blood cells. So give yourself a tick if you got that one. The plasma though has lots of functions. It transports all sorts of things. So let's have a look at the list and see if you got one of these. So it can transport proteins, dissolved substances, food molecules, urea, hormones, or blood cells. So either one of those would get you your third mark there. So tick it if you got them right, correct it if you need to. And let's move on. So C, platelets are fragments of cells. So here's my little picture here. You've got a blood vessel there, that could be an artery or a vein, and you've got little white blood cells and red blood cells, and see some platelets and the tiny little bits of plasma, and they're just little bits of cells, and they help your blood to clot. So if you've ever cut yourself and got a scab, we've all been there, we all know that. That's just where your platelets are helping the blood to clot. And the question asks, what might happen if the blood didn't clot? So I'm going to give you 2 low-level answers, which you'll see in red, and then I'll give you 2 better GCSE answers in green. All the answers are correct, but some are a little bit more scientific. So you might have said that bleeding wouldn't stop. You might have said you might bleed to death, which is a bit dramatic. Okay, perfectly fine. But better to say that you could lose a lot of blood, or you might bleed internally. Okay, that's similar to what a bruise is. So you bleed internally. So red ones are fine, green ones are better. So any one of those would get you the mark. Okay, question 3, brand new question. Now this one's quite a tricky one. Lots of students get this the wrong way round, and I'm not surprised. If this was on a ruler, this would be a lot easier to understand. What we need to do is calculate the percentage of the blood. And a percentage means you've got to times something by 100, because that's what a percent means, per 100. So we need to put that into our calculation. So we're looking at plasma. So the first thing I would do is work out how much plasma I've got in the test tube. And I've got 5.5 centimetre cubes. And there are 10 centimetre cubes altogether in there. So 5.5 out of the 10 is plasma. And that's where we start in our equation. We say 5.5 divided by the 10, and then we turn it into a percentage by multiplying by 100. And we get 55% to get you 2 marks. Now, I know when you look at this diagram, the line there is quite hard to see. Is it 5.5? Is it 5.4? Okay, I kind of agree with that, and the mark scheme does as well. They're really friendly. They will give you an acceptable answer between 54 and 56%. So if you've got 54, 55, 56%, then you've got both marks. Well done. Right, 3B. Name 3 substances, but not blood cells. So hopefully you've read that and you haven't written blood cells, that are transported by the plasma. And there's all sorts of substances transported by the plasma, and what you're looking for are 3. So here's my list. Move my head out of the way again. So here's my list. You just need 3 from here. So amino acids, antibodies, antitoxins, all the way down to urea, vitamins and water. So I suggest that you pause the video, see if you've got 3 of these substances. If you haven't, then just write them in. And if you have, well done, just tick them off. Okay, I'm going to move on now then. So I forgot about that bit. There's a little picture there to help you with this as well, that you might want to print off and then put into your revision folder. Okay, so that has only taken about 15 minutes to go through. For a normal lesson you'd have 50 minutes, so there is something else that I would like you to do for this. What I'd like you to do is copy out the table here. So question 1A, 1B, 1C, all the way down to 3A and 3B. And what I've done, I've copied how many marks each question is worth. And what I'd like you to do is to add up the marks you've got of each section and write it in, and then tally it at the end out of 21. Once you've done that, what I'd like you to do is make a checklist of the areas you now need to look over and revise. So for example, if you look at 1F and you got 0 out of 2, you'd have to go back and go, oh, I didn't do very well in 1F. That's one of the areas I now need to revise. And then once you know which areas you need to revise, okay, what I want you to do is make a little revision postcard. So that's about half of an A4 page, nothing exhaustive. And I put a revision postcard. I just want you to recap the parts that you didn't get. There's no point revising what you've got right. There's no point revising what you already know. So just make a little revision card about the things that you didn't quite get right. Once you've done that, what I'd like you to do is take a photo of your work and upload it to your teacher so they can see that you have completed this task. Okay, as always, if you have any questions, then please speak to your teacher. Just send them a message and they'll be happy to help. So that's the end of this, and I look forward to seeing you later on in the week. Take care and stay safe, everybody. Cheers.